Everybody, today we're going to find the distance between 2 points like on a graph, and that's actually connected to the Pythagorean theorem. So on our first problem, it wants us to find the distance between 4, 9 and 9, 10. So I'm just going to graph those on my graph right here. And I have those 2 points. The distance, it may be tempting to say that that distance is 5 because that's how many squares are between the points. But if you look, 5 is actually this distance, and the distance we want to find is like that. And that diagonal distance is a little bit longer than 5. So we can't say that that distance is 5. We can, however, use the Pythagorean theorem to help us. Right here, I've found that this is the distance I want, and it's the diagonal or the hypotenuse of a right triangle. So these other sides are going to be our A and B, or the legs of that right triangle. In order to find that x, it's actually really easy. It's going to be exactly the same as what we've been doing every day. We're going to put into our formula a squared plus b squared equals c squared. And then my A is 1, 2, 3, 4, 5 squares long. So I'm going to have 5 squared there. And then B is just 1. And C, I don't know, it's the one we're trying to find. I'm going to make that one be x. Now let's simplify our numbers here. 5 squared is 25, and 1 squared is 1. So I have 25 plus 1 is x squared. That's so easy. I'm just going to go ahead and write 26 right there. Then to find the distance there, I'm going to take, remember, we got to take the square root because we wanted to find x, not x squared. And the square root of 26 is 5 point a bunch of numbers, but when you round those, you're going to get 5.1. So 5.1 is my distance there. And I'm going to say that the distance between those 2 points is 5.1 units. If your problem were to say that the units are measured in feet or centimeters or something, then that's what you'd put. But because we don't have a measurement, we're just going to put units. Let's go ahead and do that on this other example over here. I'm going to graph my dots. Remember that they are x, y, and x, y, and x goes left or right. So we're going to go 1, 0, and we have a point right there. And then 10 to the right and 8 up. We have a point there. No, those points are a lot farther apart, which doesn't look quite as friendly, but we still want to find this distance right here. This is our x. And if you look, it still makes a right triangle like this. So here's my A, here's my B, and I'm going to go ahead and solve the Pythagorean theorem for x. So let's write a squared plus b squared equals c squared. And then we're going to put in the distance for A. It goes from 1 to 10, so that's actually 9 squares long. And B goes from 0 to 8, so it's 8 squares long. Then I'm going to simplify those. 9 squared is 81, and 8 squared is 64, and c squared is c squared. And 81 plus 64 is 145. Now I need to find c, so I'm going to undo that square by taking the square root. I don't know the square root of 145 off the top of my head, so I'm going to go ahead and use my calculator. And I get C equals 12.04159. Yeah, so I'm just going to put that it's 12.04. On this assignment, I'd like you to round to the nearest tenth, but I wanted to make sure that this is not quite 12, because it may be tempting to say that it's exactly 12. That's why I put 12.04 instead of 12. Then we're going to write that the distance is 12.04 units. Now, you could use this all the time. You could just graph it, but sometimes a graph is not provided and you want to just find the distance really easily. So there's actually something called the distance formula, and I never memorized it and went to college and felt really bad because I never memorized it. well, I have it memorized now, but when I was in college, everybody would just rattle off the distance formula and I didn't know what they were talking about. So one way that you could do it is you could just straight up graph all these and use the Pythagorean theorem. But I'm going to show you what the distance formula is and how we get that from the Pythagorean theorem. Let's start off with our a squared plus b squared equals c squared. Our distance is always the hypotenuse of the right triangle. So we're actually going to always solve for c, which means that we're always taking the square root of a squared and b squared and c squared. So really what we're getting is c equals the square root of a squared plus b squared. Now that looks a little ugly, but that's the best way how to get it. It's gonna get a little uglier because we don't actually know what a and b are. Our points that we're given have x's and y's. If you remember from before when we did slope, when we have 2 points, xy, xy, we actually label them so that the first point is x1, y1, because that's the first point, and then the second point is x2, y2. So I'm going to go ahead and use those variables in my formula here. So to find a, I went from 1 to 10, so it's like I subtracted 10 minus 1. And 10 and 1 are x2 and x1. If you look up here, here's my 10, here's my 1, x2, x1. So I'm going to write my a as x2 minus x1. Oh, I wrote this as exponents accidentally. Remember that it needs to be a subscript or a number below in order to just be a label. And then after I subtracted those, I squared it. And to say that we squared it after subtracting them, we put these parentheses around and then we put a little 2. Then we added b squared. So b is, how I found that is I took from 8 to 0, I subtracted 8 minus 0. So that's y2 minus y1. So I'm going to put y2 minus y1 and square that. And then I took the square root of the whole thing. Now this formula looks really long. This is the distance formula. We say d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. It's super long. But if you can remember it, then you won't have to graph anymore. You can just subtract the y values and subtract the x values and square those numbers, then add them and take the square root. So you could really just put everything in your calculator and be done with it. However, if the graphing way makes the most sense to you, then use that way on your homework and have a good time finding some hypotenuses of right triangles. All right, thanks guys. That's our lesson for today.